Okay, in the next problem we have another motion problem. This is not a graph of velocity, but of acceleration this time. We're told that a car is traveling on a straight road with velocity 55 feet per second at time t equals 0. Now we're also told that for t is greater than or equal to 0, less than or equal to 18, the car's acceleration is the piecewise linear function defined by the graph above. So we want to find out whether the velocity of the car is increasing at t equals 2 seconds. So velocity will be increasing at t equals 2 if v prime of 2 is greater than 0. And since v prime of 2 is acceleration, and since the value of acceleration when time is 2 is 15, so since v prime of 2 is equal to a of 2, which is 15, then the velocity is increasing there. That's part A. Now part B asks, at what time in the interval from 0 to 18, other than at t equals 0, is the velocity equal to 55 seconds? Well, if you look at it, the velocity is increasing from 0 to 6, then it's decreasing from 6 to 16, and then it's increasing again from 16 to 18. So we have a relative max at 6 and a relative minimum at 16. Now to answer this question, you really want to use a spatial, a geometric argument here. We start off at 55, and then we increased the volume, the velocity, by whatever the area under that curve is from 0 to 6. Now after that we're going to start decreasing. So if we ever decrease by the same amount that we increase by from 0 to 6, you can see that we kind of have a symmetry there in the shapes from 0 to 6 and from 6 to 12. And at those two places, those two areas under there will cancel each other out. So at t equals 12, so v equals 12, rather v of 12 is equal to v of 0 at that point. Now from that point we continue to decrease further from 12 to 16, and then we start increasing. So if the amount that we increase cancels out with this additional area that we increase from 16 to 18, then we would be back to 55 again, but you can see that it doesn't work that way. So for part B, the answer is going to be at t equals 12. And the explanation would be similar to what I just stated. We started at 55, then at t and increased from there to t equals 6. We could actually calculate the velocity at a number of these places. So let's do that real quick. V of 6 would be 55 plus 60, and that would be 115. We've already stated that V of 12 is equal to 55. V of 16 is going to be 10 because that green area there reduces the velocity by 45 feet per second. And the final amount that we increase by, so you can see that the velocity goes from 55, then increases to 115, then decreases and hits 55, continues to decrease all the way down to 10 feet per second, and then increases back up to 25 feet where it stops there. Okay, for part C, on the time interval from 0 to 18, what is the car's absolute maximum velocity, and at what time does it occur? Well, since velocity is a continuous function on 0 to 18, by the extreme value theorem, velocity must have an absolute max, and this will occur at either critical values or endpoints. And so we make our table. The critical values are going to be where v prime is 0. That's where acceleration is 0. That's at 6 and 16. The endpoints are 0 and 18. And we've already calculated the values that we need. And the absolute max velocity is 115. The time it occurs is 6. Now part D asks if at any time in that interval is the velocity equal to 0. And using the same argument for absolute maximum, we can say that the minimum occurs at v of t is equal to 10. That was when t is equal to 16, and since that's the minimum value, at no time then will the velocity equal 0.